So now that we know how to transform functions and make more complicated functions out of basic ones that way, we have need of a library of basic functions to do those transformations to. And that's what we're going to do in this section. We're going to go through a library of basic functions. Now these are all functions that we've seen before in this course, although some of them we haven't seen their graphs yet. So we'll begin with the most basic function, which often falls into the category of so easy it's hard. The very most basic thing that a function can do is whatever input you give it, it gives the same output. And that's called a constant function. They're of the form f of x equals some number. The example I've shown here is f of x equals 1. And technically, every constant function is a transformation of this one. We can, for example, say f of x is whatever constant we want times 1, and treat it as a vertical scaling of this one. In practice, because they are so very simple, we treat each constant function as its own basic function. But they really are all the same thing. So for any input, it gives output c. It can take any input. Its domain is all real numbers. Its range is just that one number, c, that it gives as output. Now clearly, this function is as far from being one-to-one as you can get, so it has no inverse. It is, however, symmetric. If we replace x by negative x, well, there are no variables in the expression of this function, so nothing changes. This is an even function. It has no asymptotes, and typically we don't bother with key points when graphing something like this, since it is, after all, just a horizontal line. But if we need some, we can pick any x values we like and pair them with that constant, which gives us our horizontal line. Somewhat more complicated, but also often more familiar, is a linear function. Now, we think of our basic linear function as being the simplest linear function, f of x equals x, which is what we see here. Now you might be thinking, where's the slope and the intercept? And the answer is that that slope-intercept form or the point-slope form are transformations of this basic function. The slope and the y-intercept, well, that's a vertical scale and a vertical translation. If we throw in that x minus x naught, that's a horizontal translation as well. We think of the basic linear function as just this identity function, the function that gives its input back as output. And then all the rest of that linear stuff, it's all transformations. So the domain of our basic linear function is negative infinity to infinity. And of course, since its input and its output are always the same, its range is also negative infinity to infinity. And its inverse is just itself. It's easy to see looking at the graph that this function is an odd function. If we rotate it 180 degrees around the origin, it stays the same. Linear functions don't have asymptotes, and if we go to graph them, we'll typically transform the key points 0, 0, and 1, 1. Sometimes we'll set up our transformations very carefully. In particular, if our slope is a fraction, we'll make clever use of the associative property to treat the denominator as a horizontal scale and the numerator as a vertical scale, which allows us to transform that point 1, 1 to a nice integer pair. Now I've mentioned horizontal lines and diagonal lines. What about vertical lines? Is that a constant function? Well, no, a constant function is always a horizontal line. I'm not going to mention vertical lines in this context because a vertical line is not a function at all. Remember, to be a function, a graph needs to pass the vertical line test. No vertical line crosses it more than once. In terms of the actual variables underlying that, no x value can be associated with more than one y value. But on a vertical line, the same x value is associated with every y value. It's about as far from being a function as you can get. So horizontal lines are functions, but vertical lines are not.